Chapter 33, Fundamentals of Hydraulic and Air over Hydraulic Braking Systems. Day 2, Video 9, Vacuum Booster. So we can use, if we've got an engine that creates vacuum, right? So not a turbo diesel engine, but either a naturally aspirated diesel engine or a naturally aspirated gasoline engine will create vacuum. So we can use that vacuum to create using the booster to increase the braking pressure that's created in the master cylinder. So we'll do that. Vacuum booster with or the servo, they'll call it, works on pressure differential between two sides of the piston that is inside the brake booster. So connected to the intake manifold here is the inlet. So it's vacuum, which means the vacuum is an absence of pressure, right? So we've got a vacuum acting on the coming into the brake booster. We've got a check valve, so the vacuum would open that valve up and allow it to pull more air out of the brake booster, and again creating a low pressure area here. So an absence of pressure is a vacuum. So it's creating a vacuum in this entire chamber across here. Is that if that engine were to shut down, the vacuum would pull this diaphragm closed and trap that vacuum inside the vacuum booster. Right, so we've got an absence of pressure or a negative pressure acting on this side of the piston here and here. The diaphragm separating the two sides. And then atmospheric pressure can come in and act on this side of the piston. So if we've had a negative pressure and then atmospheric pressure here, this piston is going to move this way, pushing the piston, the primary piston in the master cylinder, creating the pressure. So we've got the vacuum side here, we've got atmospheric pressure here. As it opens and closes this atmospheric valve to let that happen. The connection between here, this reactionary pistons where it moves back and forth to add braking effort, hold braking effort, or release braking effort in the brake boosters done through the reaction disc. Brake pedal, my foot pushing down on the brake pedal, mechanical linkage coming through here and working on that reaction disc. Okay, so absence of pressure on this side, no pressure on this side, and then we've got a return spring here pushing this piston back. Right. So in this case, we've got an equal state of vacuum here, absence of pressure. This spring strong enough to push this, to overcome that vacuum and push the piston against the seat here, and no atmospheric pressure here, right? So we have an imbalance. That's why we have the spring pressure is pushing that piston to the neutral position. I make a brake application. I push down the brake pedal, 5 pounds of force, right? This is linkage going to come through, act on the reactionary disc, okay? So that 5 pounds of pressure coming in here is going to upset the balance that we had before, and that's going to open up this atmospheric valve. So I have absence of pressure here, or vacuum. I would now allow atmospheric pressure to come in and act on this side of the piston, pushing the piston that way. I've got vacuum pulling the piston this way, so we would overcome that spring, and now the linkage or the push rod would come through and push against the primary piston in the master cylinder, creating the brake pressure. Right? So when that 5 pounds of force that I'm pushing down here equalizes inside of the booster, right? We have an equilibrium in there. The vacuum pulling, the pressure here, and the spring pressure all equalize. This reactionary disc will shuttle, move, and not allow any pressure in or out, effectively holding this piston right where it's at and holding that 5 or 10 pounds of brake force on the master cylinder. All right. So we've created that holding situation. Now I let my foot off of the brake, right? And now I've upset that equilibrium again, right? I've closed this off to atmospheric pressure. I've got vacuum on this side, but then the strong piston on this side, no pressure pushing the piston this way, and now the spring overcomes the vacuum, shuttles the diaphragm and the piston back to its neutral state, and we're back to no brake pressure being applied to the master cylinder. I can review. So foot off the brake pedal, we have vacuum open on both sides of the diaphragm, so it's equal pressure, no power assist. Driver pushes on the pedal. Atmospheric pressure enters the rear side of the diaphragm and helps to assist in pushing that diaphragm, or the diaphragm this way and applying the brakes. Right. Stage 3, driver holds the pedal at a certain point. Vacuum valve moves the position that maintains pressure between the two sides, holds at a steady level. All right. And then we talked about, the Brewster has a large volume in here, so enough vacuum in there to make several 2 to 3 brake stops before we run out of vacuum and we no longer have any boost.